This section is Unit 2, Lesson 4, and we're going to talk about solving and graphing compound inequalities. You should have had compound inequalities in Algebra 1. We're going to actually start with just some basic inequalities from pre-algebra to make sure you're remembering some of the special rules that go along with inequalities, and then we'll move on into the compound inequalities. And really, this entire section is a review of Algebra 1. We really only need this so that when we get into the absolute value equations and inequalities, they're a little bit easier to understand because a lot of these same principles are used. So just to review real quick how to graph an inequality, let's say you've gone through and you've solved the inequality, you've done all the work, and the answer that you end up with is x is less than or equal to -2. What you would do is you would draw a graph, just a little simple graph is fine, and then you're going to graph x is less than or equal to -2. So at -2, I'm going to put a solid dot. I make it solid because this is x is less than or equal to. If it were just less than, it would be an open dot there. And then x is less than -2 represent the numbers to the left of -2. So I'm going to shade in the entire rest of the graph to the left of my solid dot. When I shade in the graph, I shade it on the number line. I do not put it above the number line. I don't put it below the number line. I shade on the number line, and then I shade or darken the arrow here to signify that it goes on forever. Please be specific when you graph your inequalities. A lot of kids try to make up their own rules here, and then when they get to something, a standardized test or something, they don't know what they're looking at. So please do it like this. Don't try to make up your own rules, okay? And the next one, x is greater than 3. This one would be an open circle because it's just greater than, there is no equal to. So I have an open circle at 3, and then x is greater than 3 means we shade to the right of 3. And I always tell my students, if you're graphing an inequality, okay, I always tell them to make sure their variable is to the left, because that way if the variable is to the left, then all we have to do is shade in the direction that the inequality is pointing. So if the variable's on the left, you shade in the direction the inequality is pointing. Variable's on the left, I shade in the direction it's pointing. It makes it a lot easier to remember which direction to go. Now, there's one special rule with graphing inequalities that you need to remember, and that is when you multiply or divide by a negative number, you have to flip that inequality the other direction. So let's just talk about, what if they're both positive? Well, if I'm going to solve this inequality, I'm going to divide both sides by 2, and so I have x is less than 3. Here I have to divide by a -2 to solve that inequality. And since I'm dividing by a negative, I have to flip the inequality the other direction. Now, why does this work? Well, if you think about it, if you just think of two numbers that are different, I'm just going to say, okay, how about 2 and 10? Now, from your knowledge of math, you know 2 is less than 10, okay? Well, what if we were to take both sides of that inequality and divide it by a positive number? And I'll say a positive even number, so I'll get a nice whole number answer. Well, if I divide both sides by 2, I get 1 is less than 5. That's still a true statement. But look what happens if I take that same inequality, 2 is less than 10, and this time I divide both sides by a negative number. I divide by a -2. Well, 2 divided by -2 is -1. 10 divided by -2 is -5. Now, if I keep the less than sign, is -1 less than -5? It's not. See, dividing by a negative makes us have to flip the inequality around. And the same thing is going to happen if I have two numbers, like let's just say I have 2 is less than 10, and I multiply by a negative. Let's just say -1. If I multiply by -1, I have -2 and -10, and now -10 is less than -2. I have to flip the inequality around to keep it accurate. Here I have an inequality that I'm going to solve and then graph. Well, the first thing I'm going to do when I solve this is I'm going to distribute on both sides. So when I do that, I'm going to have 2x minus 8 plus 2 is greater than or equal to 4x minus 4 minus 10. Then I'm going to add like terms on each side. And this is all Algebra 1. You should be very familiar with this. Solving an inequality or an equation, very simple process at this point. I'm going to get the x values to the other side. So if I subtract the 4x from both sides, I have negative 2x minus 6 is greater than or equal to negative 14. I'm going to add the 6 over, so negative 2x is greater than or equal to negative 14 plus 6 is negative 8. And then I'm going to divide by a negative 2. And we know if we divide by a negative, we have to flip the inequality around. So that's x is less than or equal to 4. So if I'm going to graph that inequality answer, I'm going to just put the number that I ended up with, a 4, on my number line. This is going to be a solid dot because it's less than or equal to. And then since x is less than or equal to 4, I'm going to shade in the direction that it's pointing because x is on the left. So I will shade directly on top of the number line, right there on the number line, and I will shade the arrow to signify that it goes forever. In this segment, we're going to talk about how to graph compound inequalities. Basically, a compound inequality is two inequalities in one problem. And you have two different types of compound inequalities. They could be and inequalities or inequalities. And so we would have to account for whether it says and or in our graph. And that's a pretty significant difference when we're talking about what could potentially be graphed on the number line. So first I want to look at an and problem. If we have an and inequality, I always tell my students that if it's an and inequality, what we're going to do is we're going to graph it like normal, except at first we're going to graph the inequality above the number line, and then we're going to look at where we overlap, where those two things overlap. If there's an overlap in the two lines that we graph above the number line, that overlap is what we would include in our graph. So if it's an and, we graph it above the number line. So what I'm going to do is I'm just going to draw a simple number line, and I'm going to put the 2 and the negative 3 on my number line. Now make sure when you do this, a common mistake here is people say, okay, 2 goes here, negative 3 goes here, but we do have to make sure that the order that they would be listed on the number line is correct. So negative 3 is smaller than 2, so I'm going to put it on the left of the 2 on my number line. And then I'm going to graph each of these separately and then look at them together to determine what will go in my final graph. So remember, it's an and, so I'm going to graph above the number line. So at 2, it's an open circle. It will be an open circle, and it's shaded to the left. And then at negative 3, it's open, and it's shaded to the right. So if you look at this graph, you can see that the overlap doesn't start until we get right here. We've got 2 graphs here. That's where my overlap will begin. So when I graph an and inequality, I'm only allowed to graph where they overlap on my final answer. My final graph is always going to be on the original number line. Now, whatever these are up here is what goes on your number line in your final answer. So they're both going to be open circles. And then I will shade where the overlap is in the graph that I did above. So for this one, a number that is both less than 2 and greater than negative 3 would be between negative 3 and 2 on that number line. So you have to really consider what the word and means. You have to have numbers graphed that are both less than 2 and greater than negative 3 at the same time. And the numbers between those two would be included in that graph. Now let's look at an or inequality, okay? If it's an or inequality, we will graph on the line. So everything that is here will be graphed regardless. So if I have an or inequality, I'm going to do the same thing. Still my -3 goes here. My 2 is to the right of the -3. Now we don't have to be real accurate. We don't have to include the -2, -1, 0, 1 in between. It's okay to do it like this. Just be very simple with it. X is greater than or equal to 2. That's a closed circle at 2. And if it's greater than or equal, it's going to be shaded right in the direction that it's pointing. So that's that section. And then X is greater than -3. Well, it's an open circle at -3. X is greater than -3. I also shade to the right. And what happens here is that actually ends up being my graph. It kind of goes over top of what we've already graphed. It's all included here. If it's an or inequality, no matter what, everything is included on your graph, just like you have done your individual graph. So everything will be included. Anytime you have two inequalities listed as one long problem like this, that's going to be an and. So if they make it look like one big long problem with two inequalities in that same problem, it will be an and. And to graph this, well, first of all, I need to understand that it's an and, so that's the word that's going to be there. And my two inequalities are -1 is less than or equal to x, and x is less than or equal to 5. So that middle part goes with both sides. And then I'm going to rewrite this one so that the x is to the left, so that I know which direction to shade, okay? Anytime I flip so that the variable's on the left, I flip the inequality around. Now, since this one is an and, I will graph above the number line. So I need my two lines. The two numbers I'm graphing here are -1 and 5. At -1, I have a closed circle, and it's shaded to the right. At 5, I have a closed circle. It's shaded to the left. And you see I have overlap between those two solid dots. So I'll have a solid dot here, a solid dot here, and the overlap is in between those two dots. Now, does that mean if it's an and, every single time it will be shaded in the middle? No, absolutely not. Don't make that mistake. That's a common mistake I see a lot of times. People think that always happens. I'm going to show you some examples where that doesn't happen. All right, look at this one. This one is an or. It says x is greater than -2 or x is less than 3. So this one's an or, so I'm going to graph on the number line. I need my -2 and my 3. At -2, it's an open circle, and it's shaded to the right. So I'm just going to shade from there directly on the number line. I just do each of these separately like they're two separate answers. So that's directly on the number line. Shade my arrow. At 3, it's an open circle, but now look, we've already shaded through the 3. So even though this says it's supposed to be open, it's been shaded through, okay? So that ends up shading that in, and then from the 3, I'm going to shade to the left, and look what happens at my open circle here. It's also being shaded in. This is one of our special cases. You can only have this happen if it's an or. And when this happens and everything on the entire graph is shaded in, our answer is going to be all real numbers, okay? So if everything ends up being shaded, the answer is all real numbers. In this one's an and, so I'm going to graph above my number line. -10 is less than -4, so I'll put that on the left. At -4, it's a closed circle. It's greater than, so it's shaded to the right. At -10, it's a closed circle, and it's shaded to the left. This is our second special case. Where do these two overlap? Where does this line and this line, where do they overlap? Well, they don't. Notice here we had an overlap where both of those lines above the number line overlapped each other. These two never overlap. That's the second special case. Think about what and means. Can we have a number larger than -4 and at the same time it's smaller than -10? We can't. It's impossible to have that. So when you end up with something like this that has no overlap, that is a null set. There is no answer. There is no number that fits both of those situations. You can't have a number greater than -4 and less than -10. No such number exists. So that's null set. This is another and. We will graph above the line. -6 is smaller than -2. X is greater than or equal to -2. That's a closed circle, shaded to the right. X is greater than -6. That's an open circle, shaded to the right. Now this one's a little different. Where is the overlap in this one? It's not in the middle. See that? The overlap is from -2 on. So whatever is here, that closed circle goes here, and I shade where my overlap ended up being on my two graphs. So there's my shading. I do not need an open circle here. None of this had any overlap, so we don't include any of that in the graph. Next, we're going to solve compound and graph compound inequalities. First, I'm going to start with a couple of and inequalities. We're going to solve and then graph them, and then we'll move on to the or inequalities. Then I'll get you to try some on your own. In this one, we know that it's an and inequality because everything is listed as one long strand of a problem. There is no or in the problem. If it's an or, it will say or in the original problem. If it doesn't say anything and you have two inequalities in the same line, you know it has to be an and. And just like we said before, this middle section has to go with each inequality to set it up. So 13 is less than 2x plus 7 is one of our inequalities. And then that middle term, or the middle part, 2x plus 7 is less than or equal to 17, is the second inequality. And since they were all one big strand and there was no word in between, we know it's going to be an and. Okay? Then we're going to solve the inequality just like normal. So I'm going to subtract the 7 over. So 6 is less than 2x. If I divide by 2, 3 is less than x. And then to make graphing easier, I'm going to get the x to the left. X is greater than 3. Then in this one, I'm going to subtract the 7, divide by 2. So here I have x is greater than 3 and x is less than or equal to 5. So if we look at that, we're going to put 3 and 5 on the number line. It's an and, so I know I graph above the line. At 3, it's an open circle, shaded to the right. At 5, it's a closed circle, shaded to the left. My overlap is in between the two circles. This one was open, so at 3 I have an open circle. At 5, I have a closed circle, and the overlap is in the middle. So there is my graph. In our second example, it is also an and because it's one long strand of a math problem. I'm going to separate it. I have 6 is less than or equal to -2 times x minus 5 on the left, and -2 times x minus 5 is less than or equal to -10 on the right. Then I'm going to solve each inequality separately. So I'm going to distribute the -2, subtract the 10, divide by -2. If we divide by a negative, remember we have to flip the inequality. So if I divide by -2 on both sides, I have 2 is greater than or equal to x. I flipped it around because I divided by a negative. And then to make my graphing easier, I want the x on the left. So I'm going to flip it again. For this one, I distribute the -2, subtract the 10, divide by -2 again. When I divide by negative, I have to flip the inequality around. And so then to graph this, I have a 2 and a 10. It's an and, so I will graph above the number line. At the 2, it's a closed circle, shaded left. At the 10, it's a closed circle, shaded right. And hopefully here you notice there is no overlap between those two lines that we drew above. Since there is no overlap, this one is a null set. There are no answers that would match or that would go in there and form a true statement. This example is an OR inequality. If it's an OR inequality, we can't write it as one long inequality. It has to be separated by the word OR. So if it's an OR, it will be given away in the beginning. You know which type it has to be. Remember, in an OR, we will graph on the line. But first, we're going to have to solve everything. So I'm going to distribute. I've got 3x plus 6 is greater than -12. I subtract the 6. 3x is greater than -18. I divide by 3. So that is x is greater than -6. On this side, I subtract the 3 over. 9 is less than x. And then I need to flip it so that the x is to the left. So I would flip my inequality around. This one's an OR. I would graph on the line. -6 is to the left of 9. X is greater than -6. That's an open circle at -6. I graph this on the number line since it's an OR. So I'm shading to the right of -6, filling in that entire graph. And then x is greater than 9, open circle at 9, but it's already shaded in. And I shade to the right of 9. So this is my graph for this function. Here I have two compound inequalities. Go ahead and copy them down, pause the video, work them out on your own, and then I'll show you the answers in a few minutes. For this one, I solved them separately. I divided by 2, got x is less than 5, multiplied by -2, so I flipped the inequality around, got -6. It's an OR, so I graphed directly on the number line. -6 is to the left of 5 on my number line. At 5, it's an open circle shaded left. At -6, it's a closed circle shaded left, but that had already closed it in, so my graph looks like that. For my second example, it's an AND inequality. I had to separate them first. So -23 is less than or equal to 7x minus 2 goes on the left. And in the middle, 7x minus 2 is less than or equal to 12 goes on the right. Then I solve each inequality separately. I add the 2, get -21. I divide by 7, get -3. I need my x on the left. So I flipped it around. X is greater than or equal to -3. And then here, I added the 2 over, got 14, divided by 7, got 2. X is less than or equal to 2. Then to graph it, it's an AND, so I know I graph above the number line. -3 is to the left of 2 on the number line. At -3, I graph above. -3 is shaded, and it's a closed circle and shaded to the right. At 2, it's a closed circle shaded to the left. And we can see that the overlap starts here and goes to here. So we've got an overlap from -3 to 2 to finish off our graph.